Hello, Jeff.
Hi.
Thank you for taking your time to do this interview. I represent an international education magazine.
Yes, I remember you.
There are a few questions I'd like to ask you today. On the website of Internet Technology University, ITUniversity.us, you mentioned integrated software and knowledge engineering. Can you elaborate on this?
There are two distinguished sciences and practices. One is on software development and another is on knowledge engineering or ontology science. We, and I mean the whole industry, work on integrating these two together. We try to make smarter our software by embedding some knowledge learning process there. And we borrow this process and methods from knowledge engineering. Our company, Internet Technology Systems, a branch of ITUniversity, has several patents in this area. For example, the patent knowledge-driven architecture describes an accelerated way of building software applications. Another patent, Adaptive Robot Systems, describes in details how to build robots that can learn on the go and build new skills as system services.
This still sounds too scientific and a bit futuristic. What are the benefits that can be visible today?
These systems can be implemented today, although it is not a trivial work. Our core interest is in the methods that help accumulate knowledge in computer-readable form, and then how to use this knowledge in selected applications. A couple of numbers just to give you an idea of a scale of opportunities. According to the US statistics, a year's salary for knowledge workers, and I mean white and blue collar workers, it is approximately $6 trillion. 6 and 12 zeros. About 40% of their time and budget is spent on searching for information. Google is a universal engine providing hundreds of links in response to every keyword, helping everyone in a universal way. We estimate saving about 10% of time and budget, or about $600 billion a year. Internet Technology Systems work on a different solution. It is a customized, client-defined solution with estimated 1 to 3% of market, which is about $100 billion and more. We focus on new methods and tools of building smart cloud solutions with specialized knowledge domains based on clients' needs.
Can you clarify what kind of services you offer with these applications?
Knowledge delivery as a service. We offer a specialized system that learns customer needs while conversing with the customer. The system is getting better and better in understanding customer interests. The system uses publicly available sources to collect this information daily in a private custom cloud. The conversational system includes a semantic engine to retrieve meaningful information from many data layers. Even this information is not well visible to a reader. The service effectively creates specialized knowledge domains in the client-defined areas. This is not only greatly improving search. Knowledge domains open more opportunities.
Now this makes more sense to me. Do you understand correctly that information is collected into so-called ontologies, which are understandable to the computers? And another question is about more opportunities. What are those?
Good questions. First of all, about ontology. Ontology word has two meanings. It is a science of handling knowledge, and the same word represents a special form of information. This is usually a graph of connected subjects or meaningful concepts. Think of this graph as a knowledge tree, similar to a decision tree but with a wider scope. Another comparison is between ontology and taxonomy. Taxonomy pays attention to the keywords. Taxonomy uses keywords as tags to search for information. Let's say we have a sentence. Alexander Pushkin was born in Russia. Taxonomy would pay attention just to the place and the name. Ontology would also pick up the relationships between these two and will create a wider scope of information with a graph, and this graph allows later on to ask questions. For example, what is Russia? More formal and detail-oriented ontology elevates information to the level understood by computers.
You mentioned new opportunities. Can you be more specific and give us some examples?
For example, creating corporate knowledge factory. Corporate knowledge or know-how can be split into three categories. Structured data, it's data in relational databases. Unstructured data, text, documents, business descriptions, websites, folders. And the biggest portion of information is actually never captured. It is so-called tribal knowledge. Tribal knowledge is used daily in every business routine. My conservative estimate of the ratio between these three categories is 10% of structured data, 20% of unstructured text data, and 70% of uncaptured tribal knowledge. And what I currently see as a common process, not in all companies, but in some companies, by retiring baby boomers and replacing experienced and expensive with young and cheap workforce, companies actively lose huge portions of knowledge. We developed the methods and the system that not only integrate structured and unstructured data, but also help collecting so-called tribal knowledge. This is a conversational system that combines the power of big data and semantic technologies with expertise of a subject matter expert. As a result, the system helps to create corporate knowledge factory as the base for conversational decision-making systems.
Very interesting. Can you expand on robots?
I like it. Robots. Another opportunity that I mentioned before is about adaptive robot systems. Today, robots are very specialized. They are born with predefined set of skills. The patented system combines service-oriented architecture and semantic technology with robotics. Built in the system, conversational semantic support allows robots to translate situational requirements and instructions into adaptive behavior models and built-in services. So they develop behavior models that go down as service scenarios and go down to executable services that becoming robot skills. In the process, robots communicate to each other to integrate information from different knowledge domains, because each robot has specialized knowledge domain, knows specific things. If necessary, robots can communicate to subject matter experts to gain knowledge that are not built there. The use case expands on service-oriented architecture. It orchestrates services into business scenarios and up to behavior models. A common case of new situations and ambiguous instructions is resolved via computer-human communications.
This sounds very ambitious.
It is ambitious, but actually, this is a starting point for even more ambitious use cases. Integrated software and knowledge engineering leads to truly collaborative human-robot development. What we call today a development lifecycle with multiple layers and teams. This will be replaced by conversational design and manufacturing. A powerful combination of human intuition and computer restlessness is expanded by the conversational approach. Computer uses ontology to map human instructions to the knowledge tree. For example, an application developer, not a programmer, builds a web application and starts with a sentence. User has to log in. A computer with the service ontology finds the mapping between the word login and existing service authentication service. And computer will ask to confirm, do you think of an authentication service? And if a user says yes, the computer will go to the next branch and will offer another branch of code. It will offer user privileges. It will ask, first of all, do you think user will have some privileges, and will list optional privileges. And user just checked necessary boxes, and new block of code is ready. Block by block, it is building an application, and this is how direct realization of promise by service-oriented architecture happens. Building application by a business user as an orchestration of services. It was impossible without this conversational semantic support. It is possible today. Another example, more complicated one. Let's say a user wants to build an airplane that is also a car. And user knows how to do this, but not in the details. User misses some detail levels, and computer can patch, can breach this gap, providing necessary details. This is real collaboration.
Some of these topics are new to me. Do we have schools teaching these subjects?
It is a relatively new subject. Some universities include data science as a course, and in some schools there are some subjects on foundation of artificial intelligence. At university, Internet Technology University, we focus on integrated software and knowledge engineering, how this subject as whole helps to build intelligent applications. So we start from software foundation, we add foundation of artificial intelligence, and we integrate it all together with necessary tools, big data, and semantic support, and we build projects with intelligent goals. This is how our students become experts in this area.